Every blink removes part of the world. Not from reality itself, but from what reaches awareness. A small region in each eye has no visual receptors, a blind spot. Yet nothing ever looks missing. Edges stay complete. Shadows stay continuous. Even colours feel stable. Something is quietly filling the gaps, and it never announces itself. That is the first tension. What is seen is not fully what is received. Walk into a room, look around. Now close one eye. A portion of the scene disappears, yet the room still feels intact. No holes, no missing pieces. A question appears here. Why does absence not feel like absence? The answer is not memory alone. It is prediction, a continuous guess about what should be there. Signals from the eyes are not immediate. Light takes time to be processed. So does sound. So does touch. By the time information is registered, the environment has already changed slightly. Not dramatically, but enough to matter. So the system does something unusual. It does not wait. It projects forward. This is where predictive processing becomes relevant. The brain combines incoming signals with prior expectations, a constant balancing process. When input is unclear, prior expectations dominate. When input is strong, it corrects them. Perception becomes a negotiation, not a recording, a construction under constraint. A simple example reveals this. The blind spot in each eye. Light falling there produces no signal, yet vision remains uninterrupted. The missing region is filled automatically, based on surrounding structure, based on learned consistency. No conscious correction is needed. A gap exists physically, but not perceptually. Here is a shift in perspective. If missing data can disappear from awareness, how much of perception is actually seen? Hearing behaves similarly. A word masked by noise is still understood. A missing phoneme is often reconstructed. The brain fills in based on context, not by guessing randomly, but by probability. What is most likely is what is perceived, even when it was never fully received. Touch follows the same principle. Running fingers over a surface does not register every microscopic detail. Instead, patterns are inferred. Texture becomes a simplified model. Edges are sharpened or smoothed depending on expectation. The experience feels continuous, even though the input is incomplete. Color perception is another example. Physical light has measurable wavelengths, but perceived color depends on surrounding conditions. The same surface can appear different under different lighting. The brain stabilizes this variability. It adjusts interpretation to maintain consistency. What is experienced is not raw light, but corrected interpretation of light. A cognitive conflict appears here. If perception depends on correction, then what counts as the original signal? There is no direct access to it, only processed output. Now consider motion. A fast-moving object like a ball or car. The visual system receives delayed information, so it predicts where the object will be, not where it was. At normal speeds, this works smoothly. At extreme speeds, distortions appear. Motion can look slowed or smeared. Not because reality changes, but because prediction and input temporarily misalign. This reveals a key mechanism. Perception prioritizes continuity over accuracy. A slightly wrong, continuous world is preferred over a perfectly accurate, broken one. This is not a choice. It is an optimization constraint. At this point, something important becomes visible. Perception is not built for truth. It is built for stability under uncertainty. This system is efficient, but not neutral. When signals are weak, expectations dominate. When signals are ambiguous, interpretation fills the gap. When signals are missing, nothing feels missing. The correction process is invisible. Until it fails, then illusions appear. Optical illusions are not errors of vision, they are collisions between prediction and input. A mismatch becomes visible only when the system cannot reconcile it. At that moment, perception briefly breaks coherence, and the underlying mechanism is exposed. Now the system-level layer becomes clearer. This is not happening in one location. It is distributed across visual areas, auditory areas, somatosensory processing, all running parallel prediction loops, each one adjusting based on error signals. A continuous update cycle. Memory joins this system. Recall is not playback, it is reconstruction. A remembered face is rebuilt from fragments. A remembered place is filled with assumptions. Details often feel accurate, even when they were never explicitly stored. Memory and perception share the same architecture. Both rely on reconstruction under constraints. A second cognitive break appears here. If both perception and memory are reconstructed, then experience is never a direct record of anything, only a continuously updated model. This is where predictive systems in AI become a useful analogy. Image compression does something similar. Missing pixels are estimated from surrounding structure. Language models predict next words from context, not by knowing truth, but by selecting the most probable continuation. The brain operates in a comparable way, but in real time, across multiple senses. Now the system reveals its trade-off. Precision is sacrificed for speed. Completeness is sacrificed for stability. Raw data is never fully preserved. Only what is useful for maintaining a coherent world model. A subtle disruption makes this visible. A shadow that behaves slightly unexpectedly. A face that appears briefly off. A sound that does not match expectation. In these moments, prediction fails for a fraction of a second, and awareness catches the correction process itself, normally invisible, now briefly exposed. At the system level, perception becomes a continuous loop. Input arrives to prediction is generated, mismatch is corrected, experience stabilizes. This loop runs constantly, without interruption, without awareness of its own operation. And yet everything experienced depends on it. Color, depth, motion, time continuity. Even the sense of now, all stabilized through prediction. A final structural shift appears here. If experience is a stabilized prediction system, then what is the boundary between perception and construction? No clear boundary is visible in the mechanism. Only continuous updating. Only probabilistic alignment. Only correction loops that never stop. And that leads to the final unresolved tension. If what is seen is partly prediction, and what is remembered is reconstruction, then what part of experience is ever directly accessed? Not as philosophy, but as mechanism, a system question, not an answer, only a remaining gap in the model.